All right, we're at the last section of chapter 14, 8, and its other applications of fluid dynamics. And we have here an airplane wing, cross-sectional view of an airplane wing, and the air approaching from the right is deflected downward by the wing. So we imagine the air going in this direction. It's the same as the plane going in this direction. Now, as sorry about that. As these streams, as the stream splits over here, this stream is going to meet up at, you know, the same particles are going to meet up over on this side. So in order for them to go, you can see this one has a shorter path. This one that has a longer path, they have to go faster in order to meet up over here. So we have because of the tilt of the wing, this is pushing, but there's a Bernoulli effect. The fact that if you remember the Bernoulli of the pressure, the higher the velocity, there's a decrease in pressure. So there's a pressure pushing on this side, and there's a decrease of pressure over here, and so that causes lift. But there's also a factor called drag. So that is that's why the wings are shaped this way. But now, if you uh, angle this wing too much, you get turbulence, which will the which will cause the um, a disruption in the lift. So you have to be uh, careful to maintain the right angle. So that is the basic uh, of an airfoil. The speed here on the bottom and the higher speed on the top causes because of the Bernoulli effect, causes the lower pressure here, and this pressure is greater than this pressure, and so you get lift. And the lift depends on several factors: the speed of the airplane, the area of the wing's curvature, and the angle between the wing and the horizontal. So again, as the angle between the wing and the horizontal increases, that you can get turbulent flow, which can set in above the wing to reduce lift. Um, Now, that's one application of fluid dynamics. There's others. This is a shot of Denver. Well, Denver, they call it the Mile High City. It's like 1,610 meters above sea level, so the air is less dense, and that's why from the opening picture of the airplane taking off in Denver, it has to it needs a longer distance on the runway for the aircraft to move to reach higher speeds needed to get the lift. Um, so some other factors that influence lift are the shape of the object, the object's orientation with respect to the fluid flow, any spinning motion the object might have, and the texture of the object. And that brings us to our next slide, the golf ball. The golf ball has these dimples on it that increase the friction. They increase the friction force between the ball and the air. So the air adheres to the ball's surface, and the when you hit the golf ball with a club, because of its angle, it tends to put a backspin. Um, the It puts a backspin on the rotation of the ball, and because the ball is actually pushing the air down, which the air ends up pushing the ball up. Without the dimples, the friction uh, force is lowered, and the golf ball doesn't travel as far. Um, you get the same thing in a the on the threads on a baseball. The spinning of it is what allows the ball to grab the air, and it can be deflected and give you a curveball. And I believe that's it. That's the end of lecture. So that completes chapter 14.